Hey folks, good morning, good afternoon, and good evening to all who all are joining us globally. Hope you all are doing good. I am Parth Varu, event planner for Microsoft Reactor India, and I welcome you all to Azure Happy Hours along with Reshmi. I would now like to bring in Reshmi. Hi
Hey
Reshmi,
there. Hi, Parth.
how are you
Finally,
doing?
we have you on screen.
Yep.
I'm doing great. I hope everyone who's watching it is doing great as well.
Yep. So what do we have today?
Yeah, we actually have a very exciting topic today, something which has been catching the development world of trend very lately. And we have a great person who has worked firsthand on it to explain how it works. So I don't want to break the suspense yet. I want to let her introduce the product, but maybe like I'll give you a
Before
minute and then we'll jump. Yeah.
before we begin, let's go through our code of conduct. Please take a moment to read our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, being kind and considerate in the way you all engage. And obviously, yes, we do encourage you all to participate. Please drop all your questions in the chat section. I would now request Reshmi to bring in Radhika, who is the speaker for today's session.
Awesome. Thank you so much, Parth. I'm gonna take the limelight. And let me tell you, I am filling really big shoes over here by trying to be the Vivek of the show. But hey, I mean, there is a start for every time, right? So let's do this. So before we bring the speaker, let me just tell you how excited we are to start and share the series with you. And about the product, I am sure you're gonna love this. So let's bring in Radhika. So, hi Radhika.
Hey, hi Rashmi, how are you?
Hi, I'm doing great. Do you want to tell us a little bit about yourself before we go to the product?
Oh, yeah, definitely, sure. Yeah, hello everyone. Hope you are doing well. Good evening, good morning if anyone else joined from some other regions. Myself, Radhika, I'm engineering manager with Microsoft. I have been working with Microsoft for about 6 years. Prior to that, worked with Oracle for some time and then Broadcom. I have vast experience in building from enterprise products on-prem, now cloud, building distributed applications. Currently at Microsoft, I handle DAPR, which is distributed application runtime that we are going to talk about it in some time.
Awesome. That has been pretty much like a teaser for what we are going to do. So, thank you so much for that. And a quick introduction of myself. So, I am Reshmi. I am a PM in Azure Static Web Apps team. And I am working since the last 1.5 years, I think. I've done a couple of reactor happy hour sessions. I know a few folks who are there in the call has personally met me as well. So I am super excited to hear from you, give to the community what they want. And today, as per the community ask, we have Radhika on stage. So Radhika, the floor is yours. Let me know whenever you're ready to share the screen.
Yeah, give me a minute. I'll
Yeah,
share
yeah,
my
no
screen.
worries. Meanwhile, let me just quickly check the chat. I see people have come in from across the globe. I see Romania. I see Gujarat, India. Wow, guys. I'm glad everyone's very excited to watch the show as well. And yes, Nish, our personal fan. Awesome.
Is my screen visible, Rashmi?
Your screen is visible. So let's start off. Maybe we can start off by what exactly is Dapper?
Yeah, I think DAPR, as you all know, it's a distributed application runtime, and why it is named like this, and why DAPR, all that we would cover, what it is, why it is, and what it gives to the developers, and a brief about DAPR bindings in today's session. Um, with that, I will get into some introduction. In the current world, the expectations from the customer has been increasing, right? The customer has very low tolerance for any applications which are with low availability or high latencies, and also the responsibility of developers has been increasing to build very highly scalable systems and thinking of future growth, especially in the cloud or in the consumer space, where we need to think about futuristic growth as well to support the future scale. And while focusing on that, the other aspects of managing the service for long term, the flexibility of operating it, the operational costs, and the different run times as given the nature of the applications as growing, right? Today, sticking to one particular language is kind of not going to solve the problem. So it's going the technology is evolving, and then a lot of tools built in different languages we use. So to we need to developer need to cater to having the focus or knowledge on all these languages. So covering all this, when if you have to cover all this landscape for a developer, it is really hard, right? Day by day, putting all these efforts. And if we look at the tools that we have in the industry today, which to catering all the needs, which there is no one tool that would solve the purpose of all these things, right? So again, there is a lot of learning and managing these tools will come into picture if for each of these segments that we talked about, if I have to use different tools. So, considering all that, to simplify some of the developer efforts, where making uh, uh, to make work simplified for developers, where developers can focus more on their core business logic, while and forget about the other aspects that which we just spoke about, the monitoring, infrastructure, scaling, all that, right? So all
Mm-hmm.
those things can be to extract from the developers' efforts. We
Mm-hmm.
have come up with the solution called DAPR, which is a distributed application runtime. As the name itself indicates, it's a portable, event-driven runtime that's built for all type of environments. It can be any cloud, any language, any infrastructure, any operating system. You can use this DAPR in that ecosystem. So
That sounds
DAP,
amazing. Radhika, if I were to summarize this in one line, you're
yeah,
saying that DAPR, that is Distributed Application Runtime, provides as an additional layer which reduces our effort in doing a lot of day-to-day technical activities like observability, connections, configurations, connecting to multiple clouds. Everything is going to be taken care of us by that one single piece in between, and it's going to help in our day-to-day developer productivity. Am I getting it right?
correct, right.
Beautiful. I am impressed already.
Awesome. Yeah, and it's a set of bunch of APIs that and it's really we'll talk about in the subsequent slides,
Mm-hmm.
how easy it is to deploy or configure, and what are the addition the architecture of the DAPR and how it is being designed or layered, and what
Mm-hmm.
benefits it gives, and what the different components that that DAPR can talk to. All that we'll talk in the subsequent slides. With that, I
Sounds
will
great.
move on to the next slide.
Yes, let's do this.
Yeah. So I think before getting on to the architecture, right, I wanted to highlight a brief on the goals that are being considered or captured when DAPR is being built. right? And what DAPR has to offer for the customers, right?
Mm-hmm.
And when we're talking about you saying that developers, you just focus on the business logic and the rest of the stuff you outsource or externalize to DAPR, and DAPR will take care of it, right? When we are saying
Mm-hmm.
that, there are certain goals kept in mind, and the real benefits that developers will get in there is several design patterns that we use day in and out in our developing applications. So Dapper has considered best of all these design patterns that best suit for all type of environments, be it cloud or edge or bare metal, right? Any language. And we do have different design patterns for different languages. So it consolidated, considered all that, and based on that, the different building blocks has been designed, which we will
Mm-hmm.
talk about what the building block is in the next slide. And while for the developers, it also brings in the consistency when you're writing your APIs or writing your applications. It enforces a consistent approach in designing your code. And it also gives the flexibility of extensibility and then the different components that you can integrate with. So
Mm-hmm.
generally, if you talk about any distributed application, right, and when you're
Mm-hmm.
building microservices, which can be stateless or stateful, which need to be highly resilient, secure, right? When we talk about,
Right.
so when we are building all that, and for every micro, since it's the microservices has, each service has its own responsibility, and to
Mm-hmm.
handle that responsibility, it has to interact with different components, right? Be it storing in the database, or be it retrieving the configurations, or uh, the certificates, or the user authentication details, anything, right? So
Mm-hmm.
this the service has to deal with the different components, right? And Dapper gives a flexibility that with the simple easy configuration, you can talk to any of these components. And today, Dapper supports set of components, which I will explain in the subsequent slide. But
Mm-hmm.
if I want to use a component which is not in the Dapper inventory today, I
Mm-hmm.
can simply bring in my own component, and with the simple configuration and code, I can add the new component and still leverage the Dapper. So that's the flexibility that Dapper will bring in. And it's really easy to even to add a new component and leverage Dapper into your application.
Yeah, can I take a minute and just say, I think the biggest highlights for me in this slide when I'm going through the points is
Mm,
the ease of flexibility, portability, and highlight on platform agnostic. Because as of today, if you're looking at the developer sphere, it is really important that we provide as much flexibility for the developer to be able to put the best resources together. And
mm,
usually when you have like certain constraints that, hey, dapper will work only with A and B, and for C, I'm sorry, we won't support that right now. Because we don't do that, we don't stop them, right? We are telling them, bring your best platform, cloud, APIs, bring it, and we are here to take it in and give it to you. So I really love that part.
cool. Yeah. And the other thing, yeah, I think it's you summarized it really nice, Reshmi. And I think in addition to that, one more point just I wanted to highlight. I think following the standards, right? Standardizing your code implementation is also really an important aspect, especially when you're working with larger teams, distributed teams. So maintaining the standards in your code for better maintainability from long term is really important. And given where you're in, when using Dapper, when we externalize the common operations to Dapper, so it
Mhm.
enforces some sort of standardization also, where
Correct.
when your application is talking to different application or different component, so everything is driven via Dapper. So Dapper runs in a particular way, right? Dapper connects to these components in one particular way. So it inherently it brings in that standardization also for the developers. That's
Correct.
another biggest
Correct.
advantage. Yeah,
Yeah.
and we do have
Also,
one. Sorry, go ahead, Rashmi.
no, I was just I wanted to confirm this because at least in my head, from what I remember, it's that. But Dapper is also open source, right?
Correct. We do have Dapper, we do have open source, and we do have Azure version too, both version. But Azure version is very much tied to a specific services. Today,
Mm-hmm.
we support Dapper in AKS as an extension, and
Mm-hmm.
we also have Dapper embedded into container apps. Is container apps is a new managed containerized environment for hosting the microservices,
Mm-hmm.
whereas AKS is more of a infrastructure to be managed by the customers. But these two service we have Azure version supported in these two services on Azure.
Awesome.
But
Okay.
as it, there will not be much of no difference on the capabilities or the features
Hmm.
that what open source have today when we integrate Dapper in these Azure services.
Mm-hmm.
There is no difference in the capabilities.
Got it. Yeah. But yeah, open source, anything and everything. I'm a big advocate. Even for static web apps, the CLI we have is completely open source. So, yay,
Mm.
Dapper. Awesome. So, we can go to the next slide then.
Yeah. All right. Okay. So this is okay. Before going to since Reshma, you mentioned the point of open source and the current even the mindset also, right? People mind the
Hmm.
customers mindset also. There is lot of affinity or the interest, a growing interest in using the open source technologies.
That's correct.
So yeah, and I think especially the CNCF is a cloud native cloud foundation,
Hmm.
which is a governing body for several of these cloud native applications, right? So Dapper is a CNCF certified open source product. It is it's in the incubation phase right now. So I think so. It's really which means that the CNCF governs certain guidelines
Hmm.
if it has to be certified by them, which means that the security, right, the compliance norms, all those things are really a standard version. So which means that even
Got
if
it. Yeah.
I'm yeah you're using open source, still you are really
It's a
using a
regulated
standard
open
version.
source.
Yeah,
Yeah.
yeah,
Got it.
yeah.
Yeah.
Okay, so now coming into a bit of architecture of Dapper, as we spoke about the building blocks in the previous screen. As you see, your application can be running in any code, any framework. All right, it can be Python, Java, any runtime. It can be any
Hmm.
runtime, and your hosting platform can be anything. As you we see in the screen, it can be Azure, AWS, Alibaba, or Kubernetes, or virtual machine, or physical machine. It can be anywhere hosted. So the Dapper sits along with your application in any of these infrastructure laid down at the
Hmm.
application layer. Dapper runs at the application layer. It has a set of building blocks. As I said, that we took all the different design principles, design patterns for each the top common operations that every distributed application requires, right? Like be
Right.
it service to service integration or the database storing the content into database. The state management is really essential, right? For every application you need a database. So it enforces certain standards, guidelines, and certain
Hmm.
approach for dealing the operations with the state management. And we support several components on the state management side. Then in other thing is the public publish and subscribe. especially in the today in the distributed applications. Okay, so there's a lot of operations which is like highly event driven operations, right? Event driven programming model
Mm-hmm.
is standard right now used across.
Mm-hmm.
PubSub plays a I think, high role, and typically every distributed application, if we have to scale, and which we deal with asynchronous operations, right? So the messaging systems like the PubSub model plays a big role. So we have that pattern, which is well designed, well structured pattern supported. Then the other thing is resource bindings and triggers.
Mm-hmm.
As if you take up any, even a simple example, any enterprise e-commerce platform or e-commerce systems, right?
Mm-hmm.
Where you have behind the scenes, these are different services. It can be even completely different systems. Also, your payment service might be managed by someone else. You're actually the host. The UI front end might be managed by some vendor, and then the payment is managed by a different vendor, and then the other processing can be managed by a different vendor. These are the different external systems, but still well connected, right? From the
Mm-hmm.
user point of view, if you say, these are very well connected.
Mm-hmm. Yeah.
So that's where the bindings comes into picture, where so as a developer, if I have to implement the integrations, right, for these three different systems, if I have to write
Mm-hmm.
lot of code. And again, my code is very much local or bound to be defined for these three systems, correct? So then the bindings, the advantage, the bindings or PubSub or in all these things come, the advantage they brings in, right? In
Mm-hmm.
your application, you just define, right, what are the additional integration you have to use. If I take an example of the e-commerce scenario itself, where I
Mm-hmm.
placed an order, I placed him in, I added a cart, I placed an order, then I go and make a payment, and then payment
Mm-hmm.
confirmation receives, then order delivery is placed in the queue, right?
Right.
So yeah, so when as an in e-com, I mean the cart or the order placement is happening in one system, and then the payment is happening on the other system. So
Mm-hmm.
here, what we can use is the bindings, which I'm talking about, bindings and triggers, where I can use, okay, once the order confirmation is done, which is an event that happened in the order processing system. Based on the event, that event would be input. Okay, I will receive that event from DAPR side. We take that event. Then based on that event, I invoke another call, which is an external, I will call a payment system, which is another third party system, right, which is
Mm-hmm.
external to my application. So there I can use output binding, where I can call an external resource, and push the payload from this order management system to the payment system for payment processing. So there the bindings would be a really a good use case to use it there. Then the next thing is actors. This is another, the great design pattern has been built in primarily to handle the concurrency, especially when you have large scale systems, global system deployed across, and then when you have huge number of users connected to the system, handling the concurrency is really, really utmost important, right?
Mm-hmm.
So the actor model that what we have in Dapper will bring up that value add, where it makes it treats each individual request as a one thread, and
Mm-hmm.
process it seamlessly. So that's how the concurrency is handled seamlessly. That's the advantage actors will bring in.
Radhika, a question on the actors part. Does that also work as the authentication authorization equivalent in Dapper? Is that how we're seeing it? Like certain
No,
people
no.
will have certain accesses?
No, authentication authorization happens at the different layer, Rashmi. Okay.
Okay,
So
okay.
actor says once the authentication authorization is done, then if a user is take a case of order placement itself, right? Okay, so where if you go to Amazon website, you are trying to place an order for a particular item, and and there might be five items in the cart, right? In the inventory, and when
Mhm.
users are six users are coming and placing a request,
Mhm.
so how do we handle that? Okay, so for the first five users, the inventory has to be made available. The first users must be served seamlessly, while the
Mhm.
last user also, where the inventory is not available but should be served seamlessly, right? There should be a
Right.
seamless communication to the user.
Right. Right. Yeah.
Yeah.
Cool.
So
Makes sense.
yeah, that's okay.
Radhika, also, we do have one question in the audience chat. Would you like to
Hmm.
take it now?
Yeah, sure. Yeah.
Yeah. So this is Virish asking, does Dapper have its own distributed tracing or does it use other open source softwares like Zipkin?
Open source like
Zipkin.
Zipkin. Okay, so it
Yeah.
uses Zipkin. Dapper uses Zipkin for the 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 messaging mechanisms. It uses Zipkin. We support that.
Okay.
Yeah.
Awesome. Yeah. And we do have a big fan also, Sandeep, who has made sure all the answers are also coming through in the chat and explained why and how they are a big advocate of Dapper.
Mm-hmm.
So later on, you should definitely check out the chat.
Yeah, sure.
Awesome.
Awesome.
Let's go back to the explanation. Yeah.
Yeah, sure. Then the next one we have observability. I think monitoring, tracking the health of the system is really important, right? So Dapper has the a great ability, and lot of customers do use Dapper for even observability, also to track the end-to-end requests, traceability of the end-to-end requests. So Dapper has the observability where we have built-in leveraged the open telemetry model. So we expose all the traces, and we are open telemetry collector, and then customers can configure any of the monitoring tools like Dynatrace
Mm-hmm.
or
Data.
Datadog or App Insights, right? So any of these monitoring tools they can configure to Dapper, which is the OTel collector will read the traces from the application and publishes to any of these monitoring solutions.
Yes, correct.
Yeah.
Awesome.
Then the
While
yeah,
you're speaking, Radhika, let me tell you, questions are incoming on and off. So I'm going to let you complete the slide and
yeah,
then you will be getting a good set of interaction with the customers.
sure. I think after this slide we will take those, Rashmi. Yeah.
Yes, yes.
Yeah.
Yeah.
Cool. Okay, then the secrets. So as we were talking about, especially when we are interacting with the different systems in the distributed architecture, so the handshake or the authenticity of these different services is really important. So the we use the authentication tokens or the certificates that we use for authenticating across the services.
Mm-hmm.
The that the secrets is the building block that would support where you can connect which an application can connect to different type of vaults, be it Azure Key Vault or a Google Key Management System or HashiCorp Key Vault, any based on the technology that you are using. So we can leverage, you can user or developer can leverage any of these secret stores and for storing their for storing their secrets. That's
Got
the
it.
secrets building block. Then the
Mm-hmm.
last one is the configuration. So I think when we are for every application you have definitely configurations, right? We need to maintain like web.config uh, or php.ini or any file php config, like which we maintain all the configurations required for that application to run. So,
Mm-hmm.
and the configurations can keep changing in between, right? So, all that we have a configuration building block where and the configurations will be stored into any of the stores like PostgreSQL or Redis store, and I as an application I can subscribe to the store as and when there is a
Mm-hmm.
change in the configuration. I can, as an application, I can listen to that. I can subscribe to that change, and based on that, I refresh the configuration values at runtime. That's the benefit that configuration building block will provide for an application. That's the scope of configuration. And
Got
another
it.
thing is, so the DAPR supports. I mean, when we are dealing with these DAPR components or the DAPR APIs,
Mm-hmm.
I can connect either through HTTP API or gRPC API.
Mm-hmm.
So since it is supporting both, there is no necessity or no need. I mean, no need that DAPR is enforcing for having any of the frameworks. Right, that is completely into the developer
Correct.
decision making. They can use any framework and leverage which type of model whatever they wanted. So
Mm.
so it works with directly works at the compute layer. So the language frameworks are completely externalized from this one.
Mm-hmm. Yeah. Again, we're talking about the flexibility. So yeah,
Yes, yeah, yeah,
great. Awesome. So I think Dapper Logical Layers has been very explanatory, especially on what behind the scenes looks like. We do
yeah,
have a bunch of questions, so if you're ready
yeah,
for them, I can start them. Yeah.
yeah, sure.
So the first one is Sandeep asking, can we say Dapper is service mesh?
Okay, that's a good question. That's the common notion we get into. That's a common understanding because of the components that what we are having today. Its architecture. So service mesh is meant for primarily for the networking aspects, right? So it service mesh runs at the networking layer, where
Mm-hmm.
DAPR runs at the application layer. However, there are certain overlaps, like if you take observability or the configurations, or then the DAPR also has the ability of resiliency. So there are some overlap between service mesh and DAPR, but service mesh is meant for primarily networking aspects for to deal your ingress or egress, right, traffic or the load balancing, right? So all such operations
Mm-hmm.
where the service mesh is primarily comes into picture, whereas DAPR is for the building blocks, the pub sub state management service invocation, which we are talking about. That is a unique thing with the DAPR, which is not there with service mesh.
Got it. Yeah. It is a very close line. No wonder people actually have that question. Now that you were explaining, I was also wondering, yeah, that's actually pretty close. But yeah,
Yeah, there is a
cool.
overlap. True.
Yeah.
Yeah.
Yeah. So now we have Nikhil asking how Dapper helps in inter-service communications.
Okay, so see, DAPR has this a concept called service to service invocation, right? So all we say that in the service invocation building block, it's a, since we have these different building blocks and we're talking about different components, how to define those configurations? We might get into such questions. So DAPR heavily depends on AML configurations. So the service to service invocation is the one where that provides that communication with services. We define that in the simple configuration. We say that okay, this is the service, this is the app, this is the API, this is the port, and all that you define in the YAML file, and DAPR would take care of that service to service invocation.
Got it. Awesome. I hope that answered the question, Nikhil. You can feel free to write a follow-up in the chat. And meanwhile, we'll pick another question. So Kalpesh has asked if you could share the use case for Dapper Actor.
DAPR actor. Okay.
Yes.
Okay. Yeah, so I think one use case which I like very much, mostly which we use, is the concurrency handling, which I was talking about, where when you have a set of operations running behind the scenes. I will take the simple example which I just explained to Reshmi when we are talking about when a particular take a case of rate limiter, right, where we have the uh, rate limiter primarily we use for controlling the number of requests coming into the application. But
Mm-hmm.
when you have that rate limiter defined behind the scenes, if your rule, the rate limiter rule is defined as the based on the number of requests coming from a specific IP example I'm taking, right? So if or the time window, if the rate limiting is defined by a time window, so I can serve only 5 requests in this time window. Example, if that is the rule defined for rate limiter,
Mm-hmm.
in that time window, if you get 6 requests, right, in at the same time, and we are telling that only 5 requests should be handled in that, right? So how do we and there can be a slight difference when the requests are hitting in uh, bit when the rate limiter itself is operating. Okay, so calculating number of requests it has come, and by the time it sets the counter behind the scenes. Yes, okay, these many requests I served. Before the counter has been set and respond back in that window, if another request comes in, which is the calculation has not completed there yet, right? So there is a
Mm-hmm.
possibility of getting more requests coming in than what the limit is defined.
Right.
So I think the actor is primarily where it can play every request. It captures and maintains that a complete end-to-end operation is completed. Um, so that's where the concurrency will be seamlessly handled, properly managed.
Mm-hmm. Got it. Yeah.
Yeah.
Yeah, I think yeah, the example when you were explaining to me kind of gave a glimpse of what it could look like when you have actors.
Mhm.
So my confusion just came out of nowhere because I was like, oh, actors, does that mean like only certain people can have certain access? That is the
Hmm.
first click that happened, but you did a good job explaining. So I am hoping Kalpesh got the answer clear. And that's all that we have right now for questions. So we can go ahead with the presentation.
Yeah, sure. Okay. Now, I think I want to give a brief view on the component, the different building blocks we spoke about, right? And
Mm-hmm.
today, for each building block, we have from DAPR already a set of components has been implemented, certified, and they are in different states. Today, total DAPR supports over 110 components.
Mm-hmm.
Spread across different clouds in each of these categories, the building blocks: state store, pub bindings, secret stores, observability. If you look at right in each of this category, the
Mm-hmm.
we have set of components. And as I said earlier, this is as from DAPR, the effort has been put in and defined the list, right? And there is as however developer or customer can bring in their own component, they can write their own component and contribute to open source, right? Then add it to the inventory, and that component would be available to all other users as well.
Yes, that's definitely a crucial for all the open source lovers there in this call. Please go ahead and help in improving all the products available so that together we build a good developer community. So yeah, sorry, I just took your spotlight, Radhika. Back to you.
No issues. Yeah, yeah. Cool. With that, we will move to a bit of uh, architecture on how Dapper runs with the application. Right? So, I think most of you might be are well aware of the sidecar pattern. This is the most used design pattern in especially in the Kubernetes environments, right? So DAPR runs as is implemented as a sidecar. It sits with your application in the same pod, um, and um, and then you can define all the configurations. So, and the operation between your app and Dapper would happen through the HTTP or gRPC APIs that I just mentioned. That's how you enable. And as you scale the number of pods based on the workload you have, as you scale and along with your app, Dapper also scales. There is no additional effort or operation is required. However,
Mm-hmm.
DAPR requires certain resources since it's again it's a process. It is running in the pod. It needs resources, but it takes very minimal.
Mm-hmm.
Yeah. So that's how it is. If you have multiple applications, you can have different applications running in different pods, and each pod can have its own Dapper instance, and you can configure the interaction between these two applications via Dapper. You application to application, you need not interface. All the interfacing can be done between from Dapper to Dapper. The service invocation I just mentioned, if it is a service call, you can leverage that. Or if it is a state store, okay, you have set of APIs in app one, but the actual database operations is handled by app two.
Mm-hmm.
Okay, which is a service B we are describing in this diagram.
Mm-hmm.
So that the database operations can be handled by the Dapper instance in this sidecar, while the service interactions with service A will be taken by a different Dapper instance in the different side in the different pod.
Got it. Yeah.
I
Awesome.
hope this explains a bit of architecture.
Yeah, we very early on in the comments itself, we saw someone who already said they use Sidecar and they're aware of it. So I think
Mm.
this definitely is one of the biggest selling points right now for Dapper. And I was very impressed when I came to know like you're in one single system, two applications interacting with each other, and they don't need a third party tool. Like Dapper will take care of the transitions and the talking. So that's definitely a very big advantage of having this feature, the sidecar architecture.
Right.
Awesome.
So, all right. With this, I will briefly share about the different hosting environments that Dapper support today. Dapper can run in Kubernetes as a sidecar, which we just spoke about, and I can also run Dapper in self-hosted mode in any
Hmm.
along with my application as a exe or as a .sh file. I can initiate it even while developing the app, right? The self-hosted mode is mostly recommended for the development while developing the apps, where I can run Dapper in my own local developer box, which requires the basic needs of which I just need a Docker desktop, and which would Dapper itself. When I initiate the Dapper init command, when I run it, it will load all the needed files,
Hmm.
uh, and uh, and then yeah, and it will download all the needed Docker files it required. Primarily the init, the three basic Docker images we use on the in the self-hosted mode, like it's a Redis for a store, then Jipkin primarily for the the tracing stuff, and these are the uh, Docker images default created when I run Dapper init, and it sets up the Dapper dev environment where I can run the different Dapper commands and integrate with the application, which I can do even from the VS Code, also Visual Studio Code. Also in Visual Studio Code, we have a Dapper extension already with Visual Studio Code.
Nice.
Either I can enable that way. Okay, that's the
Nice.
self-hosted mode. Then, and I think the virtual or physical machines I described here, if it is an individual VMs, then DAPR, where I can download DAPR and run it as an EXE. Again, it's similar to the self-hosted mode. It will run on these machines. Uh,
Mm-hmm.
we also support that if you're running on a physical machine where there is no internet available, still it is supported. All we need is you download all the needed DAPR packages. Today we support DAPR installation through via Wingit, or you CLI, you can download it.
Mm-hmm.
And then without internet, you run the installer and it sets up the complete DAPR environment for a developer to start operating on. Then the third thing is Kubernetes. So here, primarily, it will be using Helm. We can install DAPR in these environments, like you download as a Helm chat and then deploy. So it will deploy the dashboard, it will deploy the DAPR control plane, then it will inject the DAPR sidecar, where we looked at all the different building blocks that will be connected to your pods. That's
Got it.
how, yeah.
So, out of these three, Radhika, like almost all the basically Dapper is equivalent in all of the three, is my top understanding. But if customers were to opt for one of them, which is more recommended?
So for production workloads, if it is for production, we recommend Kubernetes. You use Kubernetes mode. Either it can be AKS, you might be using
Mm-hmm.
AKS or GKE or AWS version, right? It can be any of
Mm-hmm.
that. We recommend that. Uh, However, there can be applications which are still where it's not cannot be hosted in the Kubernetes environments, which will be running in virtual machines or physical machines, right? Still,
Mm-hmm.
you can use Dapper in a self-hosted mode there, and you still can use it. It's purely so far we have seen, Rashmi, majority of the customers in production, they are using in Kubernetes, their applications
Kubernetes.
hosted
Mm.
in Kubernetes. Correct. And the local development is in the self-hosted mode. But it
Got
is
it.
up
Okay.
to the use case, right? Based on your nature of your application and your use case.
Hmm. Got it. Cool.
Yeah.
We do have one question in the comment. Do you want to take it now, or should we continue with the slides first?
Yeah, sure. What is the question?
Yeah. So the question is how the integration with other applications is handled in Dapper. For example, Zipkin, DBs, pub subsystems, etc. So how does the integration handle?
Yeah. So when Dapper, I think the building blocks which we spoke in the previous slides, right? So when Dapper is configured in the setup in the ecosystem, Dapper will have internally all these APIs already, right? Along with when
Mhm.
Dapper is loaded, you all have all those APIs. It's based on your application. Say, example, I have an application where I need to have, I'm going to use a messaging system in my ecosystem, in my
Mhm.
large application processing. I need a messaging system. Say, example, take a Azure Service Bus. Then I just load only the PubSub component into my environment. Okay, I'll take PubSub component. I configure. PubSub component saying that okay, I would be using this message bus, and you define an AML file in Dapper. I will show a little bit in while talking about demo how a
Mhm.
structure would look like and AML will look like. So you load only the you configure only the PubSub component, and the Azure Service Bus is configured. So in your environment, that particular component would be loaded.
Got
So
it.
likewise, it's a purely in Dapper you already have all these APIs, but which APIs I wanted to use or which building blocks I wanted to use is completely it's my own decision. I go define the configuration, say that I need to config building block, and then what configurations I wanted to manage, which store I wanted to use, all that I will define in a configuration YAML file in DAPR, and accordingly it will load that when your system or when your pod is getting loaded.
Got it. Okay. Awesome. We have couple more questions, and also we have less time, but I am hoping that folks are interested enough to stay back for a longer session. I'll just ask one quick question again, and then maybe we can go to the next slide quickly.
Yeah.
So the question is from Sandesh, and the same has been resonated by Sandeep also. Is can we have Dapper on ARO, which is Azure Red Hat OpenShift? So both
Yeah.
of them have expressed interest in that.
Yes, yes, it can be. Yeah.
Okay, awesome. That was a quick answer. Cool. Let's jump to the next slide in that case.
Okay, so I was talking about simple configuration. Right? This is primarily how a DAPR configuration or how to operate DAPR in these different environments along with our app. So if it is a standalone mode, once I have an app, I configure, I define all the YAML files and everything. Then I will run the DAPR like this to see the different operations, right? To perform different.
Mm-hmm.
These are the commands I would use. If it is a Kubernetes, then this is how the configuration will look like. The YAML file I will define. Okay, so which app. Right, what is the app ID, which protocol it would talk to, on which port. We will define all that in the DAPR in the SAML file. So
Mm-hmm.
it is DAPR is heavily dependent on the YAML files and environment variables. So and since it's different components, different apps use, there will be a lot of ports which comes into use. But this is how the configuration will look like.
Got it.
Okay, with that, uh, I will just show the uh, just a typical setup, right? When you install Dapper, this is in a Kubernetes environment, how it would be. These are the control plane, Dapper control plane. We have cert authority, then like some of these components, and then you have an app in the pod. Then you connect with the different Dapper components here. The configuration is driven, and then your interaction. You can use these
Mhm.
components with your app. This is how
Yeah,
typically it will look.
awesome.
Okay. Yeah, with this
Folks,
we
please
will get on
keep,
to the binding. Sorry,
yeah.
Rashmi.
No, no, I was just saying, folks, please keep dropping your questions in the chat. We will keep picking it up as and when. And definitely stay tuned till the end because we do have an interesting demo as well. So back to you, Radhika.
Sure. Yeah. We will talk a little bit. I explained a little bit in detail about bindings in my previous explanation when we are talking about building blocks. So primarily bindings we use in microservices where if there is an event, right? Okay, so if a certain event is happening within your application, and based on that event, if you have to invoke an external system, right? The example which we spoke about earlier, the order management system itself,
Mm-hmm.
or I just gave an example for input binding here based on some Twitter post. If you want, I mean, your app might be performing some operation. If someone posts a comment to your some post, and based on the comment, if there is any operations your app is doing,
Mm-hmm.
so an event is occurring it in your app, and then you listen to it, or event is happening on an external system. You based on that event you perform some action, right?
Got it.
So, so in these cases, the bindings comes very handy. So, all you do in Dapper, so your external systems, the the connections with these external systems you define in Dapper configuration, and your app is transparent, right? So tomorrow, if you want to put a change into different. some other system, your binding, your connection has to change, you can just go and change in your DAPR configuration. So
Got it.
primarily, yeah, the bindings primarily used in the scenarios where if there is an event happening within your app, some event happens, and based on that, if you have to perform an action in an external system, or
Mm-hmm.
there is an action happening on an external system, and based on that, something has to happen in your app, right? So in these cases, the bindings will become handy, and
Mm-hmm.
it's highly recommended to use the bindings building block.
Got it. So Radhika, is it safe to say that bindings is equivalent to event triggers? Like it's the other name for event triggers.
Correct. Yeah,
Oh,
yeah. Event triggers, yes, you can say that. Okay, it's not only triggers, but you perform an operation also based on the trigger.
got it. Yeah. Cool. Yeah. And when we code in like JavaScript and all, usually like we set these HTTP triggers, event triggers, etc. So I
Correct.
was thinking along the same. Okay, got it. Cool. Awesome.
Yeah, I think, see, you have those triggers, right? When you're talking about the functions or the different triggers you're mentioning. And
Mm-hmm.
there, this bindings building block will becomes very handy. So there is a trigger, some
Mm-hmm.
action happened. Okay, your binding listens to that trigger, and then performs an operation, right?
Got it.
Yeah.
Awesome. Cool. We can move ahead. I think people are still grasping it and they're getting it well. That's why no questions yet. So let's do this.
All right. So a simple uh, bindings YAML will look like this, where we define which component, right? Okay, so and the API version, and if to talk to those APIs, then the token information we specify. But high level, this is how the YAML file will look like, and with using an output binding. You can have a different common like HTTP binding is most commonly used one. Then we have a cron binding. Cron is similar, like so in your application, if you keep monitoring something behind the scenes, if a particular file is, take an example of, okay, you keep monitoring for a particular file to placed in your drive, and then once that file is available, based on that you go and send a notification. Example, just I'm making out an example. In such
Mhm.
cases, for a cron will be used for continuously monitoring, right? Periodically running, and then you can define a cron binding for that to run for every 10 seconds or for every 1 minute. You
Correct.
run monitor it. Yes, the file make getting that file available is an event, right? So that's a cron. There you can use cron binding. A file have occurred, then file present, and based on that you perform an operation. You make a call to a different system to make a payment or to send an invoice. Take case of, okay, example, invoice. The file
Mm-hmm.
is available, then you post an invoice to the customer.
Got it. Yeah.
Yeah, that would be one good example.
Awesome. And for all the folks who are interested to learn more about this, we do have all the URLs coming up which talk about how to learn about bindings, what is a quick start. There is a quick application run as well, documentation. So feel free to, whenever you want to check it out in your free time, feel free to check it out and come back to us with your feedbacks because you will help us improve the product further. So back to Radhika, and now it's action time. So we're gonna see the demo.
Yeah, I think we are on time. I would not take much time for the demo, just to show, I think, to give a gist of how the different components of DAPR will look like, and the configuration specifically in my with my application, how I can define a configuration. So I have a Python app. What I have written was, this is a Python app has a cron job behind cron binding. which would be running for every 10 seconds, and then it will make a HTTP call. With that HTTP call, I'm submitting an order data into the order database. So here, running the cron job for every 10 seconds and triggering this HTTP is an input binding. Then then my app calling the Postgres SQL and storing the data into database. That's the output of binding operation I have created. Right. So we can, if we look at here, binding cron YAML, this is the input binding which will run for every 10 seconds. If you look at here, it runs for every 10 seconds, right? If you can see here, it is a component and the component name is a cron job and it is running in the quick start namespace, right? Then I have bindings Postgres YAML. This is again a component of type SQL DB, and this is the connection string I specify here. What is the database name, the port number, and the username and password. The complete connection string is also specified in this file. This is the example. This is the YAML file which we will be using for a demo, but I will show the other YAML files also, since there was a question by someone how it will look like, right? I'm taking a PubSub example. So PubSub YAML if I take. So right now in this, it is configured with Redis. So that's where you can say that type PubSub dot Redis. This is the uh, component type I have. Likewise, you can have an YAML file based on the component we are using. It can be Kafka, it can be Azure Service Bus, or anything. So likewise, for every component in DAPR, we will have bindings, and we do also have SDK. So either you can talk to these directly with the HTTP API, or if you want to implement your own client-side implementation in your app, you can use the SDKs, right? Okay, DAPR has SDKs which has the complete implementation of DAPR. You can use the any SDK that you want. It can be, today we have C Sharp, Go, Java, JavaScript, Python, and there is also Rust is also there. So one can leverage these SDKs and handle the client-side implementation if that is required based on your use case. Yeah. So these are the simple different YAML files. This is how it would look like. And resiliency is another key feature that DAPR supports today, where you can handle retries, circuit breakers, or timeouts and all that. Leveraging DAPR, you don't need to code in your app. Rather, you define that for based on the APIs that you have, define how you need to handle timeout or how need to handle retries and how many retries. Or if you want to have circuit breakers, you can define that, all that, and the resiliency. Okay. So with this, I have a Python app, as I was telling. It's based on the cron job, which will run for every 10 seconds, makes an HTTP call, and then it will submit data into the PostgreSQL. I can show here. Okay, so it will submit the order ID, customer, and price information. This is the information it will submit to PostgreSQL. That's the scenario I have created for this demo. So I'm running DAPR in my machine in the self-hosted mode. So that's where I have DAPR CLI installed on my machine. And this is how, as I have shown earlier also, how you can invoke DAPR. I can invoke like this. This is a DAPR run command I'm using. I specify the app ID. My app ID is batch SDK. It is running on this port 50051, and it has the components defined in this path, right? We have seen the YAML files, and my app name is the app.py is the actual app, my app. So I'm running this one, right? Okay, so yeah. So this is the development server. Since I'm running in the development mode, you can see it, right? So if you look at here, these are the logs it will generate on the console. And it is, you can see here, it is inserting into orders database. This is the information. So, and it runs for every 10 seconds, right? The cron job is configured to run for every 10 seconds.
Hmm.
Now I go to the database. So I have set up, I mean, I have already logged in, connected to the database. PostgreSQL is the database I have set up here. I will go, so let's start from others. Yeah, so if you look at, I mean, this is the data I have been inserting it because I've been running this operation for a longer time. So you can see that the number of records here, it keep adding it every 10 seconds. You see that the set of records will be adding it. Right. So
Right.
if you look at 36 rows are there. Now I will run again. 45 rows are there. See, it's keep inserting it here. You can see the log here as the number of iterations is going on. Um, right. So this is the output call here, and in the logs we can clearly see that what app is being running and what operation, what component has been loaded. If I scroll up a little bit here, we can clearly say that it is running on this server, okay, on which port it is waiting on, and what components it is loaded. It will show
Mhm.
clearly. Here, see, if you look at say successful init for input binding cron, this is what we are using, right? So we can clearly see again. You see successful init for output binding SQL DB. You have seen in the AML file. We are using this. We are submitting into SQL database through output binding connection. So we have exhaustive logs here, and we can capture this information from the logs. Yeah,
Awesome.
this is
That was a very
the
smooth and simple and clear demo. I am
yeah.
sure everyone who wants to get the gist of what it is should have gotten the gist now. But obviously, we are still open for questions, folks. If anyone has any questions, please feel free to drop it in the chat. And meanwhile, please do take out some time to help us understand what you loved the best in the show. What was the thing that actually like stood out for you, and how would you like us to explain better on the topics you like? So feel free to take a minute and quickly fill the survey. All the URLs which are referred in the screen regarding DAPR Bindings, the Quick Start, the GitHub repo, everything has been shared in the chat. Everything has been sent as per request. So feel free to ask any questions again. We will be moderating the chat, and we are at time. But Radhika, do you have any closing comments? How do you like this?
Yeah, it's really good. I'm doing this session for the first time. I was little nervous when I started, but you made it very comfortable, Rashmi. And
Yeah. It's
uh,
it's been really fun having you because I have learned a lot about Dapper. I wouldn't have otherwise because I did not have that sphere overlapping, right, for me to learn
mm,
Dapper. But now that I am in the show, I'm learning so much with you. So thank you so much for being so patient and explaining everything, including all the questions in the chat. And really amazing. Hope to have you soon again in the show. And
yeah,
I can see a lot of folks saying thanks as well. So looks like everyone's really happy with the session. Thanks a lot once again, Radhika.
thank you. Yeah, time just went off. Yeah.
Yeah, that's the best part, right? It just went off very smooth. It was not like, oh, okay, why is it not getting over? No, it just, everyone was so intrigued. They were just enjoying it. So perfect.
Thank
Awesome.
you.
So
Yeah.
now I need to just check with Parth on how do we do this. So Parth, are you gonna come in or do I just end the show? I'm going to hope that this is
Okay,
going to
but
be a
I'm a
good
little
one.
blurred, I guess.
Yeah, yeah, you are. You're frozen. You're black screen.
Okay, okay. So there's some congestion in the network here,
I
I
see.
guess.
Okay.
Okay.
But this is awesome part. So How do we end this? Please give me the KT for this. And thank you so much once again to everyone who participated in this show. And hope
Thank
you
you.
guys love Dapper. Hope you guys love everything Microsoft. And we'll be there very quickly again with another set of show. So please don't forget there is a show coming up about Dapper itself very soon with our very own Nish and Vivek. So this is going to be streamed as a part of samosachai.net. So if you want to learn more and see how hands-on looks like with Dapper and microservices combination, please feel free to join the show. Okay.